In this video, I will describe the main idea or the concept of mean absolute deviation. This is often abbreviated as MAD. The definition is the average distance between each data point and the mean. So, if you see a picture like this, you can imagine the mean is 6. So if we look at each of the data points here, we see that many of them, these 6, are all 0 distance from the mean. They are equal to the mean. There's no distance away from the mean. All of these points here at 7 all happen to be 1 unit away from the mean. 8 is 2 units away, and so on. If we look down at the second dot plot here, we found the mean was 5.6, would be in this range. So we have a few data points that are fairly close to the mean. But then if we look at these data points out here, they're quite a distance away. And so this is going to increase the average distance between each data point and the mean. Again, in the end, this is going to tell us a measure of variability. Again, how variable is the data? How spread out is it? So what do you think? If I have a relatively small MAD, okay, so we pretend we calculate the MAD, and the MAD, usually we capitalize it. The MAD is 0.5. That's fairly small, depending on our data. What do you think? Does that mean the data is spread out? Or does that mean the data is close together? Think about it. This is the average distance between each data point and the mean. This means, on average, the data is 0.5 units away from the mean. So this is a small mean absolute deviation, and the data is close together. But if we had a MAD that was larger, depending on, again, what we're measuring, let's say it was 3.2, compared to 0.5, that's fairly large, and that data will be more spread out. And that's the main idea of mean absolute deviation. It tells us how spread out the data is. A small MAD means the data is close together. Large means it's spread out. Again, it's just telling me the average distance. So in this case, each data point is on average 3.2 away from the mean.